y equals x squared. 4x, looks like that, right? How about I draw a better picture? Come on. It's hard to do when you can't see where you're close enough. Everyone with me there? But I'm revolving around the line y equals -2. Now, a lot of people draw their picture wrong. A lot of people draw their picture wrong. I have a lot of people put their shape here. So you've got a big old gap. So when you revolve this, you still better have a big old gap, correct? So when I pick this up and revolve it, I have a much bigger shape. So, draw this over here. So I'm going to kind of have a curve like that. But a lot of people mistakenly draw it here, and that's a big problem. That affects our radius. Big problem. So it's going to look, once again, like an empty bowl. Can you see it? Yeah. Alright, I have a big old hole, so I have to do outside, inside. Now the outside is from the radius center to the curve. And one thing that will help you out, notice on this old one, we use the original function, not the reflection, to do our radius. Same here, I'm going to use the original function, not the reflection. It really helps use what you were actually given. It's going to help. So in this case, only this distance from the axis is the function. So my radius is the function plus 2. Right, because that distance is 2. We're talking distance. Don't put plus -2. So you see I have 2 plus the function. So my radius is 2 plus, what is that function? 4x. Which let's go ahead and multiply that out now. So I have 4 plus 16x plus 16x squared. Yeah? Now the good news is, once you figured out that you're adding 2, that's what we did here, correct?
Yes.
Once you do one of them, the inside should do the exact same thing. You're never going to have a problem where the outside and inside are doing 2 different things. If I added 2 on the outside, I'm going to add 2 to the inside. Let's go ahead and look at the graph. See how this is my inside right there? So that's the function plus 2 to the inside. So I have pi 2 plus the function, which was x squared, right? Here's your case. Sometimes we add the number, sometimes we subtract. In this case, you could also look at it as we're subtracting -2, but when you look at the picture, it makes more sense to say, hey, this distance is 2, and radius is the function plus 2. You've got to have a good picture. Okay, so I have 2 plus x squared, 2 plus x squared, which give me 4 plus 4x squared plus x to the 4th. So my integral, and pull out the pi, the outside was 4 plus 16x plus 16x squared minus the inside. I'm going to go ahead and distribute, if that's all right. So I have minus 4 minus 4x squared minus x to the 4th dx. I need to figure out my bounds. I'm still looking at the x-axis, so I'm going from 0 to where they meet, correct? When x squared equals 4x, when does that happen?
4.
At 4. Right, you can take that over and factor if you need to. Okay, factor out an x. Okay, let's clean this up. So I have pi, the integral is 0 to 4. Oh, 4's cancel, that's nice. So I have, let's see, 16x plus 12x squared minus x to the fourth. Is that correct? Okay, let's take an antiderivative. What's the antiderivative of 16x? 8x squared, about 12x squared, 4x cubed, minus x to the fifth. Evaluate from 0 to 4. Plug in 4. What will I get here? I'll get 16 times 8. 128. Plus, here I'll get 64 times 4. 256. Minus, 4 to the fifth. Let's, what is it?
124, or 1,024.
You sure?
No, just one more. Okay. Oh wait, no, yeah.
Two
That's right.
more, yeah.
That's
64
right.
times 16? Yes? Well, let's check. Kind of ran out of room there.
1024.
Yeah.
Okay. And 0 we get 0, correct? Yes? Okay, 256 plus 128. Add them. 384. Oops, that's minus. So this needs a times 5. I'll get 20, carry the 2, 42, 1920 minus 1024. 886. Is that what we got? What did we do? With Bard, it was a 1. 6. Borrowed. Oh, I gave it 0, not a 1. Okay. Okay. Does that reduce? No, because it's a 5. Here we go. The hardest part is the setup. The picture is the hardest part. You have to have a correct picture or the whole thing's going to be wrong. So that's what you should be spending most of your time on. The integral themselves, that was pretty easy. Integral, just a lot of basic math, right? Pretty easy integral.